3rd of November. It is the 3rd of February. You guys, geometry, will be able to use triangle inequalities, section 6.3. So, triangle inequalities, guys. This is actually one of my favorite sections to teach, okay? But it's only fun if you guys help make it fun, okay? So, let me say that part, okay? So, it's only fun if you guys help make it fun, okay? So, I hope you guys help make it fun. Otherwise, if this lesson stinks, it's your fault. Just going to throw that out there, okay? So, let's not interrupt either, okay? So, what is the measure of angle B in this triangle at the top? How could we find that?
The same way you find it on every other problem.
Okay, how's that work? Hey, Elizabeth.
Can you do 95 plus 35? No, wait.
95 plus
Wait,
35 plus x equals 180.
Yeah, I was getting there.
Okay, so the equation 95 plus 35 plus x, angle B, equals 180. All three angles of a triangle add to 180. So we take the 95 and 35, add them together, we say, okay, well, it's 130 plus x equals 180. We subtract 130. X is 50. So what's the measure of angle B? 50 degrees, okay? So we can say now, if we want to list the angles from smallest to largest, which angle would we say is the largest? Angle A, angle B, or angle C? Angle from smallest to largest.
Oh, C.
Angle C, angle B, and angle A. Okay? We would say from smallest to biggest is the angles, okay? Well, what about sides? Okay, well, do we know any of the side lengths right now? No, we don't, do we? Okay? What if I told you, though, there's actually a way we can figure out what the side lengths are going to be? Okay? Or at the very least, we can't figure out necessarily the measure of the side lengths, but we can figure out which one's the biggest, which one's the smallest, and which one falls in the middle.
What if I told you that I know you're going to teach me, so why would I ask?
Ooh. Well, maybe ask some real questions there, okay?
It is even dark in here.
I mean, you're not going to bring it up if you're not going to teach it, so why?
I mean, you'd hope.
So
Okay.
Then just
See.
move on.
Dylan, I'm going to ask for your help here for a second, okay?
Okay, do I
Okay, I'm asking a lot of you.
Do I stand up?
Okay, nope.
Okay, good.
But I need you to grab one other folder or binder or piece of paper out of your desk.
I don't have them.
Out of your backpack, see me. Okay. So, phone, right? I have my phone here, okay? I have a flashlight on my phone. You guys can see that light versus not seeing the light?
Yep.
Okay, can you guys see that when it's on there versus not on there?
Yeah.
Okay, so now, let's say Dylan's going to take this and he's going to obstruct part of the view, okay? So he's going to angle this folder so it covers up part of it. So what happens? Can you still see the light?
Yeah.
Yeah, but you see less of it, right?
Yeah.
So it's covering less of the wall, isn't it?
Yeah.
Okay, so the part of the light showing is less, and so now it's covering less of the wall right now. Can you grab your other piece of paper there?
Sure.
Okay. And why don't you put it on this side and kind of do the same thing from the other side, but still leave some gap in the middle. So we still see some light now, right? Will we see less from each side? Okay. Maybe move the papers away again. Okay. Bigger? Okay, move back. Smaller. Okay, we see that happening, right?
Yeah.
So we see that light, and less of it's getting out. So what's happening though is if we actually form like an imaginary triangle between this light and where it's hitting the wall, or the part of this right and left it goes, what happens is as this angle becomes bigger, as Dylan moves the folders out and out this way, okay, work with me, buddy, okay, this side became what?
Try not pitching it like.
Bigger or smaller? Bigger. But as he goes and makes this angle smaller, what happened to the side?
It's gone.
It got smaller, okay? So that's actually going to be how we figure out, just like this little flashlight thing here. Okay? It's going to be, lights on, 3, 2, 1. That's going to be how we actually figure out the sizes of these sides comparatively. We can, so if angle C is a smaller angle, it's going to produce a smaller side opposite it, just like the flashlight. If angle B is slightly bigger, a slightly bigger angle, more of the flashlight's going to show. So it's going to take up more of the wall. But if angle A is an even bigger angle yet, it's going to have even more area on the wall that it's shining on, so the side's going to be even bigger.
So is angle B the flashlight?
Okay, so any of the angles could be the flashlight at different points. So you notice how the angle started out at a normal size, and it got smaller and smaller? Okay, so any of these angles would be the flashlight. And the side opposite the angle would be the wall, where the flashlight was shining on. So when the flashlight was smallest at 35 degrees, the smallest angle, what did we notice about the side on the wall? How much light it took on the wall? Was it the smallest or the biggest?
Smallest.
It was the smallest. So our smallest side is going to be side AB, the side that was opposite the smallest angle. So what would be our next smallest side, the medium side? Okay, side AC. Why is the side AC? Why is side AC our next smallest, the medium one? Nope, that's not why. What do we notice about the angle B? Is it the medium side?
Yes.
So it's going to create the medium opposite side. Because as the flashlight gets a little bit bigger than 35 degrees, it's going to create a little more light on the wall.
No way.
And so which one of these three angles is going to create the most light on the wall?
A.
Angle A. So that means this side coming all the way opposite it is going to be our biggest. Side CB or BC.
Doesn't matter which order you put in.
It does not. Thanks for asking. Okay?
I said let's go, and you just haven't responded.
Where are we going? All right. So we can see that the longest side and the largest angle are opposite each other. Okay? So the biggest angle produced the biggest side opposite it. Does everyone know what I mean by when I say the opposite side? You guys know what I mean by that?
Yes.
Okay? It's the side that's not touching it. Any angle is touching two sides at any point, but it's not touching another. And that's the one opposite it, okay? The one not touching it, across from it. Okay?
So then in the flashlight demonstration,
Yep.
it would be the same length on both the sides would be the same length though, right? It wouldn't be like off to one side like that.
I'm not sure I'm understanding what you're saying.
So like, okay, if the flashlight is A,
Okay?
so AB is shorter than AC.
Yep.
Wouldn't that mean that, but like the flashlight they'd be the same, wouldn't they?
Okay, so you're saying because the flashlight stayed at a fixed point,
Yeah.
because this side came smaller, it wouldn't shorten up like the other side necessarily.
Yeah.
It would a bit. It would have to shorten them up a little bit. But yeah,
One side wouldn't be longer than the other.
it wouldn't. What do you mean?
AC wouldn't really be longer than AB.
In that flashlight example, technically no, the way we did it. But let's say we cover up one side of the flashlight more than the other. Then would that create that?
Yeah.
Yeah. So we could go back and do that, and it would end up creating that scenario. Does that make more sense?
Yeah.
Alrighty. Any other questions about a flashlight scenario before we move on to the second part of this flashlight scenario? Okay.
I already did that.
So the smallest side, or the shortest side, and the smallest angle are also opposite each other, okay? Alright, good luck. Okay?
Yep.
Questions on that? Okay. So we're going to list the following sides and angles in order from smallest to largest. So on number 1, what's their smallest angle in this triangle? Okay? Seth, what is their smallest angle? Angle P. Okay? Ryan, what is our next smallest angle? So the medium angle in number 1.
Angle 1.
Angle R. Very good. Okay? And Bailey, what angle does that leave for our biggest angle?
Angle Q.
Angle Q. Very good. Now, do we know the side lengths at all?
No.
No, we don't know any numbers. But what is the smallest side length? Elizabeth? QR. And how do you know that?
Because it's across from angle P.
It's across or opposite angle P, which is the smallest angle. Very good, okay? So what would be our next smallest side here, okay? Someone new.
PQ.
Okay, it would be side PQ because it's opposite the next smallest angle, okay? And then what would that leave as our biggest side here, Landon?
Our biggest side would be side PR.
Very good. Side PR, which would be the last remaining side, but it's also the side opposite the biggest angle, okay? Questions on that?
No.
No.
Now let's say we go the reverse way. On number 2, do you know any of the angles right now?
No.
No, what do we know?
Down.
Side lengths, okay? So let's go by sides first. So what's our smallest side? Okay, side C to A or A to C, it doesn't matter which, okay? What's the next smallest side?
AB.
AB or BA. Okay, what's the next smallest side?
CB.
CB or BC. Now, do we think we can go the opposite way and know the angles now? If we know the sides? Yeah, so what's our smallest angle?
B.
Angle B, it's opposite the smallest side. So what's our next smallest angle?
C.
C, it's opposite the next smallest side. And then angle
A.
A. So even though we don't know the actual measures, we can know, hey, smallest to largest, here's where they fall. Okay? Does that make sense?
Yeah.
Okay? Hey guys, here's a little pattern I use to help me out with this. Okay? When I'm going from like sides to angles for, and I know CA, AB, and CB, I know those, and I'm trying to figure out the angles. I say, hey, what letter's not involved in CA? B. What letter's not involved in AB? C. What letter's not involved in CB? A. And that's the angle that would match up with it to be opposite. Because the opposite angle won't be part of the side. Because it's opposite, it's away. Same thing. When I'm going angles to sides, if I have angle P, I know it's going to be the other two letters QR. When I have angle R, I know it's going to be the other two letters PQ. And so on and so forth. So that's a pattern you guys can use if you recognize that. And if not, we can still go through the picture and just look at it and know. Questions on that?
No.
I want you guys to try number 3 on your own.
You would say the
Yep, when you have it or have questions, go ahead and raise your hand. So, right now, do we know the measure of angle C?
No.
No, we have to find it before we move on. Quentin, what does the measure of angle C end up being? Okay, 75 degrees. Do we agree with that?
No. 65.
Okay. Okay. So, thankfully, whether it was 65 or 75 doesn't change what's the biggest, the smallest, the medium, okay? So what's the smallest angle? Angle A followed by angle C followed by angle B. So what's that give us for our sides here? What's our small side?
Side BC.
Side BC. What's our next small side? AB or BA. What's the next small side? AC or CA, okay? Questions on that?
4 comedy.
Okay.
Oh. Mr. Phillips.
We're gonna skip 4 and 5. Okay.
You got 4. What are we doing? I will take a copy. One of them, I guess.
Okay. How long's a ruler? Should be 12 inches, right?
It's more like 12 and a half.
Okay. Okay. Okay, but either way, they're standard length, right?
Yeah.
Okay. So we can establish that a ruler would be a standard length. Okay. I would say, yeah, it could be more like 12 and a half. I'd say the one I have is pretty close to 12
30
though.
centimeter.
Are pretty close to just being right at 12. Some of them are like 12 and a half, like some of these academic ones.
Bothers
The big
me when
ones?
they're like-
But most of these are exactly 12. Okay.
See, you didn't like it though.
Now, it's true. Okay. So we can establish that this is a foot, right?
36.
So can I take maybe a few of these and line them up and say, hey, this is a
3 foot length.
3 foot segment.
No.
Is that okay for me to do?
No, because they're separated.
Okay.
We'll pretend that they're.
Okay. Now they're together. Okay.
Yes, nice.
So now I can say that's a 3 foot segment, right?
Yeah.
Okay. So let's say I have a 2 foot excuse me, a 3 foot segment, a 3 foot segment. I have another couple 2 foot segments. I'll have a couple 2 foot segments there.
How many feet though does it take of your feet?
How many feet? Okay. So I have a 2 foot segment here. Let's say I have another 2 foot segment. Does anyone think that they can make a triangle out of these side lengths up here?
Yes.
Okay, who wants to come up and try it? Okay, Dylan raised his hand first. Dylan, why don't you hand sanitize?
You better
Okay.
sanitize.
Oh, my shoe came on.
You gotta keep them sanitary.
Haha.
Thank you, thank you, thank you.
That was a good one.
Thank you. I was pretty proud of it. Just came off the top of my head there. So,
Hey, what's that? You playing for my shoelace in my boot.
all right. So the rules are you have to keep the side lengths the same of 3, 2, and 2.
Okay. That should
Okay.
be pretty easy.
Okay.
I think. It might.
Okay. What was that?
Nothing.
You messed it up, Alex.
We were just saying how Dylan's gonna do a good job.
No, you're saying I'm gonna mess it up.
No,
I heard it.
those words never left my mouth.
Boom.
Don't forget to fix
Okay.
it when you push, too.
Okay, I would say if Dylan maybe straightened him up here, I think he did it. Okay, I think he did a good job there.
There we go.
Now let's say I take one of these sides and instead of 3 feet,
Make 4 feet.
it's gonna be 4 feet long.
Yeah, I'm not doing
Do you think we can make one out of this?
it. Nope.
Yeah.
Okay, who wants to try it? Seth, you want to try it?
No, wait.
All right, go and sanitize, buddy.
No, you cannot do that.
Math problem to figure this out.
Oh man, wouldn't that be cool?
I think there is.
It's odd how math class there might be a formula.
Sus. It cannot work.
Yeah, if you want to move around and get a better view, feel free.
Nah, it didn't work.
You got this, man.
Come on, Seth, you can do it.
You got this, Seth. It's gonna be really tight, but you can get it.
Ooh. That's like a straight line almost.
Oh, you can't. They're both equal.
See, because you got 2 over there, 2 over there, and then you got 2 over here, 2 over here. Who would have thunk it?
No, he got it.
I was
He
gonna say,
got
it looks
it.
like he got
Oh my
it.
God.
You're not pulled back all the way though. There's not a full side length there,
Rip.
right?
R.I.P.
So I don't think you have it.
He didn't come out on top.
We gotta go all the way back to here, right?
You always gotta have one that's longer for a triangle. That's not. No, that's not true either. Because you can have one last.
All right.
Seth is determined to get this.
Seth is using his powers.
Yeah, he's using
He just picks up the ruler, stretches it out.
Valiant effort, valiant effort. Does anyone else think they can make that work
No.
for those side lengths?
Termination failed.
Without
Okay.
changing them.
Without changing the side lengths.
Oh.
Termination failed.
Nah.
Okay. Well, let's try it with some different side lengths then. Okay. So let's try. So I heard Kenny say, well, one of those other 2 sides might have to be longer. Okay. The 4, 2, and 2 wasn't quite working. So maybe
4, 3, and 3.
The 2 sides can't equal one side.
2 sides can't equal one side.
Yeah. No, that's
What do you
not.
mean by that?
2 sides. One side. If you have 3 sides, one side is bigger. The other 2 sides can't each be exactly half.
Can't each be exactly half. Okay. So
Otherwise-
what if we had 4, 3, and 1?
I can get this.
What if we had 4, 3, and 1?
I'll try again.
Okay. Go ahead, Kenny.
No, you can't do it.
I already tried.
I'm holding on right now. Greg, you want to try it?
No, you
Hey,
can't.
Greg. Greg, why don't you try a side of 4, a side of 3,
Glenn, I'll kick your butt right now.
and a side of 1?
He's gonna do it.
Start of 4, 3, and 1.
I already can figure this out.
Whoa, hey, buddy, sanitize.
Does that
My bad.
You gotta keep them sanitary. What?
Does it have to touch the end on it to make
Yep.
it a triangle?
Yep, because otherwise it's not actually connecting at the end point. That is technically shorter than the length that we're saying.
Alright. Actually, already figured this one out. What is that?
Bit off.
Kenny, what are you doing?
You see, Tyler?
Yeah, that's not happening, Cap.
Separated.
I want
It's not happening?
I want
Does anyone want to try this?
I want to redeem.
I want to give an opportunity for
Okay.
someone before Seth does it.
Hold on.
Does anyone else want to? Kenny, you want to try it? All right, Kenny, why don't you sanitize? You guys got to keep it sanitary.
Those nasty hands. So it's gonna be
Yeah.
That's
Can you get
gonna
Might be. You gotta
What?
keep them
He
sanitary.
said, Bailey said, yeah.
That's a good song.
It is though.
Dude, she must be looking at her own.
Get wrecked. Get wrecked, nerd.
Oh, you can't do this. Hold on. There's gotta be a way.
That must be
away.
Mr. Costa, may I use the restroom?
No, there's no way.
I mean, if you want to miss the mind blowing stuff, then sure.
I want
Mr. Costa's gonna blow everybody's mind and make sure it works.
They won't line up.
I want a redemption.
Hold on.
Make it
super thin.
Kenny, bring that side up.
What?
That-
it's possible if you make it super
Up? What? What do you mean up?
No, not like that. There you go. There you go, Buckaroo.
Push in closer. You can't do it. It's the same thing as Seth just did, dude.
I want redemption. Dang. Alright, Mr. Costa, you try.
Yeah.
Really suck.
I want
Well, what
redemption.
if you're saying this isn't working?
I want redemption.
Back up, please.
6
So
feet.
we're saying that this didn't work. Okay, and actually it won't work. Okay, 4, 3, and 1 will not work. I can tell you that now. Okay.
What about 4, 3, and 2?
What about 4, 3, 2? Okay, someone want to try 4, 3, 2?
I'll do it.
Someone new.
No, Mr. Costa.
Want to try? Kevin, why don't you try 4, 3, and 2?
Dude, Tyler's got it. He's not even working with full hand. He could get it.
Okay. Kevin, why don't you sanitize?
Full
Okay,
phalanges.
guys, give us some space.
Did somebody take a bite out of both sides of that ruler?
I think so.
Yeah, this one too.
Oh, Seth, don't put that in my mouth.
Mr. Costa, do you have any Gorilla Tape?
I might.
Kevin's got an unfair advantage.
No, change the door.
Because he's long.
Yeah.
Yeah, we'll just leave it there.
You'd have to have a lock. I don't need You'll need
You might need to alter that one.
enough Gorilla
No, it turns in.
So you got to use the full side thing, so it has to be over the edges there. So you know. Okay.
You can.
Can't?
Wait, are you allowed to say
This, though, like just one of them,
To do what?
you do it probably software.
to like, actually no, that, never mind.
There you go. All right. Hey, well, Kevin was able to make this one work. Kevin was able to make 4, 3, and 2. Okay. So in the alternative event, he was able to. Okay. So what changed between the ones that we couldn't make work, where it was 4, 2, and 2, and 4, 3, and 1, to where now we can make it work with this? Kenny,
An extra side length.
what are you
Yeah,
thinking?
an extra side length, so now it equals more than that one.
All right, then.
Total. The two sides together equals more than the longest side.
Okay, so he's saying that the two shorter sides are now bigger than the biggest side. Okay, when you add them together. Okay. Do we see how that works though? 3 plus 2 is 3 plus 2 bigger than 5?
Yeah.
Or
What about
3
1,
plus 2
1,
bigger than 4?
No, not
Okay, but when it didn't work,
But what about
it was
1, 1,
3.
1?
When it didn't work, it was 3, 1, and 4. Is 3 plus 1, is that bigger than 4?
No, it's the same.
No, okay. When it was 2, 2, and 4, 2 plus 2, is that bigger than 4?
Yeah, no.
No, okay. Well, the other one we had that worked was 3, 2, and 2. 2 plus 2, is that bigger than 3?
Yes.
Kenny's on to something here. Kenny's actually on to what we're going to say right now.
What about 1, 1, 1?
Guys, voice off. Okay? If we take 3 line segments, we may or may not be able to form a triangle. We just found that out, right? We just saw how sometimes it works, sometimes it doesn't. Okay? Well, what works, though, is the sum of any 2 side lengths of a triangle has to be greater than the third length. Okay? So if you take any 2 sides, if you pick any 2, whether it's the biggest 2, the smallest 2, or the other combination of 2 you can have, the biggest and the smallest, okay? It has to be bigger than the third side length. Now, when you're checking all these inequalities, okay, you really only actually need to check the one that Kenny was saying. Okay? If you check the smallest 2, so what I need you guys to know from this is if the smallest two add up to be bigger than the longest side, it's a triangle. If it doesn't, it's not a triangle. So notice, when we had up here, it's a scenario similar to the one we had where it was like a 2, 2, and 4. In this case, it's 2, 2, and 5. These red lines are where it could swing and where it could possibly swing through. Is it ever able to form a triangle?
No.
No, when it was 3, 2, and 5, that'd be similar to our 3, 1, and 4. The only time it meets is when it forms another straight line. And that's just 2 lines, not a triangle, okay? Okay. What did work though was when you had like 4 and 2 add up to be more than 5. Kevin, do you have a comment to make?
I wasn't thinking though. Like what adds up together?
To equal it? So that'd be like the 3, 2, and 5, or down here we had a 3, 1, and 4. That was the one that Seth tried, and it actually just makes a straight line. In which case, that's not a triangle if it's just 2 straight lines. Does that make sense? Yeah, great. What if? Okay. Any other questions on this? Billiam.
Wouldn't you just like remove the sides and put it up?
What do you mean by that, buddy?
Like, for example, the rulers.
Yep.
You just take one, but put another one up, and it would still be equal.
Why don't you sanitize and show me what you mean? All right. So if we change the side lengths, if we change the triangle, then it's a whole new scenario, whole new problem, so to speak. Okay. All right. So if I ask, is it possible to form a triangle with these side lengths, 8, 15, and 17? Can we form a triangle there? Okay. How do we know?
Because you can, if the two add together.
Yeah. 8 plus 15. That's 23. Is 23 bigger than 17?
Yeah.
Yeah. Last I checked, we can. Okay, so your answer is yes. Your work to show or to explain yourself is right here. Okay, what about a number 2? Could we?
No.
No, because 6 plus 8, is that bigger than 14?
No.
No, it's the same as 14. So no, you can't do it. That's one where it just makes a straight line. Okay, what about number 3? 1, 2, and 25. Ha ha ha.
Yes.
No.
No, we can't.
Big no.
Because 1 plus 2 is 3, and last I checked, 3 is less than 25, not bigger.
Nah, it's definitely.
Okay?
Yeah, that's
Don't even shake your head and laugh.
Okay? What if I give you side lengths just like randomly, like another problem here, okay? What if I say give you, I don't know, 80, 100, and 200?
Nope.
No.
No, you guys can say pretty quickly it's not, right?
No, it's only 180.
Because it's 180 when you add the 2 smallest. Okay? Now what if I give you guys these 3?
Yeah.
Yeah.
Which 2 do you actually have to add here, though?
4
6 and 4.
4 and 5. So they might not always be in the smallest, greatest order, will they? You got to be careful there, okay? Sometimes the problem might get tricky and put them in the wrong order, okay? So you still have to find the 2 smallest, not necessarily just the first 2 you see, okay? Elizabeth.
I was just gonna, you pretty much answered that.
Cool beans, cool beans.
I just needed to be a little more patient.
You're good, you're good. All right. I love that your mind's going there, okay? What about an equilateral triangle? Okay? So guys, what about an equilateral triangle? Well, 3, 3, and 3. Okay, well, if you pick any 2 side lengths, is it ever going to be less than the other side?
No.
No, so it works. Yeah. What's up? Okay. So, on number 4, can an isosceles triangle, similar to the question Seth asked, isosceles has 2 sides congruent. Can an isosceles triangle have these side lengths? 5, 5, and 10.
No.
Would make it a line.
Okay, it'd have to be 6, 6, and 10. 5, 5, and 10 would just be the straight lines. 6, 6, and 10 would work because 6 plus 6 is 12. That's bigger than 10. Okay, so no, and it was the same reason as the other ones, okay? Like 5 plus 5 is equal to 10, not bigger, okay? So the answer is no, and we have to explain that as well, okay? Questions on that at all?
No.
Yeah, Kenny.
So Landon thinks he can take and make a triangle in CAD that's 4, length of 4, and then 2 and 2.
Okay, why don't you try this?
I will.
Okay, you show me what you make.
It'll be like sometimes the software lets you go up 1 or 2. Like it might try it through that. I'll have to probably.
It'll probably try to do that to make it work.
Yeah.
Yep. Because I'm not gonna lie, I have a feeling how this is gonna turn out. Okay.
I'm gonna try it.
Okay. You try it though.
Landon.
Okay.
I'll try.
All right. So now, let's say we're just given 2 side lengths. Let's say we're given the side lengths 3 and 12. Okay. Well, do we know how big the other side has to be? No, we just know that if we add up the 2 smallest, it can't be bigger than the biggest. But what if could the side length be 4 in that scenario? Okay. Could the other side length be 4? Could it work if it was 3, 12, and 4? No, because 3 plus 4 is
It's
7. Okay, 3 plus what would work though?
10.
14.
Okay, 3 plus I heard 10.
Yeah.
That would work.
14.
Okay, could it also be 3, 11, and 12?
Yeah.
Could it be 3, 12, and 12?
Yeah.
No, yeah.
Okay, what about 3, 13, and 12?
No, it's too big.
No.
It's too big.
Yeah.
What are the two smallest sides in this scenario?
3 and 12.
3 and 12. Are 3 and do 3
Oh,
plus
wait,
12
yeah,
add up to be bigger than 13?
Yes.
Okay, what about 3, 12, and 14?
Yes.
Okay, what about 3, 12, and 15?
No.
No, why not?
They.
That one would.
Because now the two smallest sides shifted from before, where it was like 3 and the third side. Now it's 3 and 12 are the small sides. So we're noticing there's a range here. Okay, there's some sort of range here, right, as to what the third side could be.
Yeah.
Okay, so here we have some math that actually tells us how we can figure out that range that it can fall into. Okay, so you take of the two sides you're given, you take your big side minus your little side. So between 3 and 12, what do we think we're going to call the big side? Probably 12, right? What do we think we're going to call the little side?
3.
Probably 3. So you do 12 minus 3. That's going to be less than x, and that's going to be less than, you take your big side plus your little side. Now, truthfully, does the order you add matter?
No.
No. Okay, but the order you subtract does, right?
Yeah.
Okay, so the order you add matters. Okay, so 12 plus 3. So our x, aka the third side, has to be somewhere between the difference and the sum. Somewhere between 9
And 14.
and 15. It has to be somewhere between 9 and 15. Now, could it be exactly 9?
No.
No, because then it doesn't work. It's the straight lines again. Could it be exactly 15? No. But could it be 14.9?
Yes.
Yeah.
Ah.
Could it be 9.1?
Aha.
Could it be 9.00000000001?
Yes.
No.
Yeah, it would. Because then 9 plus all 0.01 would be bigger than, and 3 would give us something bigger than 12.
14.9.
Although very minuscule,
But
it'll give it something bigger.
good point.
So we can't just say 10 to 14 because it can be smaller than 10. It can be bigger than 14. So we have to say, hey, it's somewhere between 9 and 15, but it doesn't include 9 and 15. Okay, does that make sense?
Yeah.
If we were saying it includes 9 and 15, what symbol would we put? The or equal to. But we're not putting that there because it's not true.
This is probably the first one yet.
Good, good. So on number 2, we can figure out, if we have two side lengths of 4 and 9, we can figure out where that third side has to fall into this range, okay? Can someone help me figure this one out? Okay, Elizabeth, go ahead.
9 minus 4 is bigger than x. Bigger than
Boom,
9
I did
plus
it.
4.
Okay, less than, but yeah.
I mean, yeah.
So 9 minus 4, the difference, big minus little, is less than x. It's going to be on the smaller side. Okay, put it away. It's going to be on the smaller side or less than 9 plus 4. So what are the two numbers x has to be between?
5.
Has to be 5 and 13.
5 and 13.
And then numbers.
So it could be like 5.01, or it could be 8. Or it could be 9, or 10, or 11, or 12, or 12.9. But it couldn't be 13.
So this works as an answer to the problem.
That is the answer to the problem. Because we're finding out, hey, what's the possible range? Where could this third side fall in between? And we know it's somewhere here. We have no way of knowing any more specifically than this.
What about 14?
I did number 3.
Okay, 14 couldn't work.
Right? Because 5
Be-
plus 13 is
We're not, the sides aren't 5 and 13 though. The sides are 4 and 9. Which is why 14 wouldn't work. Alright, so if the sides were 14 and 10, Dylan, do you have this one?
Yeah.
Okay, how do we set this one up?
So you do 14 minus 10.
Yep.
And then you do the sign x.
Less than?
Yeah, less than sign x and then less than sign 14 plus 10. And then you add, well, you subtract and then you add. And 14 minus 10 gives you 4, and 14 plus 10 gives you 24.
So, x has to fit somewhere between 4 and 24. So that's a pretty big range, right?
Yeah.
Yeah.
It can fit anywhere between there. Okay? That got a lot bigger than like 9 to 15 and 5 to 13, okay? Quite a bit bigger, okay? Now, hey guys, hint, 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 hint. Like seriously, like listen up for this moment, okay? On a test, hint, hint. If I give you a problem like this, or a problem like this we had a moment ago, it may or may not, hint, hint, say, show your work in order to get full credit. Now that means, if you just put yes or no, do you think you would get full credit?
No.
Probably not. So, you might have to show some of your work rather than just putting yes or no. Okay? No. If a test ever happens to say, for any given spot, show your work for full credit, and you don't, did you do what the instructions asked you to? No, you didn't. And so you will not earn full credit because you did not do what it asked.
So it just says show your work and still not earn full credit. Wow.
If it specifically says to show your work, that is an instruction then at that point. Yep, great clarification.
Is explain equivalent to show your work?
Sometimes your work can be an explanation.
So that, in this situation for 4, that would be the explanation?
Yep, and for this, that would be a sufficient explanation, at least in my opinion. Alrighty guys, on to our homework.
Good thing